Hi everyone, welcome to our video on finding the equation of a tangent line using implicit differentiation and where we have a natural log involved. Alright, well, our strategy for this is the same as always for finding the equation of a tangent line. My first step is to get the derivative. Okay, so let's get our derivative. Okay, so the derivative, well, let's break it down. I want to find the derivative of this equation. No, let's go ahead and write it out because that x equals 2 might be confusing. So let's write it like this. Okay, so that's our equation, and I want to find the derivative. Okay, so the derivative of this natural log portion, remember it is to take your expression that's in the natural log, so the x minus 1, and put it in the denominator. And then the derivative of this would be in the numerator. So the derivative of x minus 1 would be 1. And then we have plus the derivative of 24 would be 0, so let's just put equals, we'll move on. And then this, well, this is pretty common. This is a product. So that means we would want to use our product rule. Remember, the product rule is if you have u times v, we do u prime v plus uv prime. All right, so it looks like my x cubed is the u, and my y is the v. So I'm just going to label it underneath. Okay, and I'm going to eyeball this, and we'll plug it in as we go. Okay, so u prime, so the derivative of x cubed is 3x squared. And then v is just y. And then we have plus u, which is x cubed. And then the derivative of y would be 1. But again, as soon as you find the derivative of a y part, attach dy dx to it. All right, and then so this is our derivative. And then what I really want, so I called this step 1. It's continuing step 1. Let's use the x value. And actually, we should use a y value. Okay, so step 1, maybe it's not actually the best first step. Typically, this is what we do, though, in all these problems. So let's save a little space. Let's go to step 2. We should maybe get the point first. Okay, because that's going to be more helpful for us up there. So the point is to use the equation. We're going to let x equal 2 into the equation. Into that natural log of x minus 1 plus 24 equals x cubed y. Okay, so if I plug 2 in, so we're going to plug the 2 in to our x's, we'll have the natural log of 2 minus 1 plus 24 equals 2 cubed y. Well, this simplifies to be just the natural log of 1 plus 24 equals 2 cubed is 8 y. The natural log of 1 is 0, so we're left with 24 is equal to 8y. And then I could divide by 8, and we'll get y is 3. Okay, so this means, so our point, when we let x equal 2, we got the point is 2, comma, and then the y was 3. Okay, so this is our point. Let's box that up. Okay, so that was important to us. It wasn't really part of an answer, but I wanted to box it anyway, because these are the x and y values that we'll plug in to get dy dx. Okay, so we did the derivative, and then now, so from here to here, so I forgot to do it in blue, so that was the derivative. And then in our next step, now we're going to let x equal the original 2, and y equals 3, which we just found, so that we could solve for dy dx. All right, so let's plug those in. So we've got 1 over x, which is 2, minus 1, equals 3 times x, which is 2, which would get squared, times y, which is 3, plus x, which is 2, getting cubed, times 1 dy dx. Well, we could just write that as dy dx, like that. All right, and then let's continue going. So I have 1 over, this all just simplifies to be 1, because 1 over 2 minus 1 would be 1 over 1, which is 1, equals, all right, 3 times 2 squared is 4, times another 3. So 3 times 4 is 12, and then 12 times 3 is 36. and then plus 2 cubed is 8, and then dy dx is still attached. Okay, my goal is to get dy dx all by itself, so it looks like the next step would be to subtract 36. And then that way I'll have negative 35 equals 8 dy dx. And so one more step, divide by 8. And there we go, and I'll have my dy dx, let's put it over here. My dy dx is equal to negative 35/8. Let's box that up. Okay, so notice we needed the point, so that this step 2 should probably really be step 1. I'm just so used to our old strategy of always finding the derivative first. But notice the point is probably better to get here. But even if you do what we did here in this video, we just know, hey, put a pause on this, just like we did, leave some space, and eventually we can come back and find it. Okay, so we found our point, we found our slope. Now that we have both of them, step 3. We have our line equation, which is y minus y1 equals m times x minus x1. And then now I'm just going to plug all those in. I have y. And notice the way that we use the point. Notice I use it as x and y in this portion. But in this portion, I'm going to use it as x1, y1. Okay, so let me go ahead and mark it 2, 3. That's our x1, that's our y1 in this equation. Okay, but I used it as x comma y in the red here in our first part. Okay, so notice the way it can be manipulated. All right, anyway, I'm going to plug those in, though, at this point. So I have y minus 3 equals the slope, which is the dy dx. Let's go ahead and say that this is imtan. We'll mark it again. So the negative 35/8 times x minus x1, which is 2. And then now I just need to solve for y. We would distribute, so we have y minus 3 equals negative 35/8 x. And then when negative 35 multiplies the negative, it would be positive. 35 times 2 is 70 over 8. Now 70 over 8 looks like it reduces. They're each divisible by 2. So it looks like I should have done 35 over 4 for a single step. That's okay. We found it either way. Okay, so it's really 35/4. Oops, and I'm getting low on room. Okay, so I'm gonna erase that 78 and just change it to 35/4 to save one line since I'm gonna run out of room. I'm gonna add the 3 to both sides, and when we add 3, so I will go ahead and start to we'll have just enough. 35/4 plus 3. Well, the 3 I would need to get a common denominator. It would be 12/4. That's the same as 3. And then that way I can add them together. 35 plus 12 is 47. So 47/4. So we have y equals negative 35/8 x plus 47/4. Okay, so that is our final answer. That is the equation of the tangent line through our weird equation here, just like that. And let's go ahead and show something. And if you don't want to see it, I mean, we are done. But I'm going to show our Desmos. I'm going to do the graphing one. Okay, so let's go to graphing calculator. And I'm going to plug that equation in. Natural log of x minus 1 plus 24 equals x cubed y. Okay, and notice it can graph it. So if we plug the equation in, it does graph it. And then let's go ahead and let's plot the point 2, 3. And then let's also plot our equation that we found. So the y equals the negative 35/8 x plus 47/4. Okay, so it looks good. It looks like we got it right because it looks like it goes through our point. There. Trying to click on it. Won't really let me too well. Okay, but that's through our point right there. And notice on the green it's going through it. There we go. Now it lets me click on it. 2, 3. Make it a little bolder. Okay, so notice it does look like that is the tangent line. It is going through that curve at that one point right here real nicely. Okay, so that's a way to quickly check, just to plug it all in. Okay, so that's it. So that's all I wanted to do was just show that. Notice the graph is really weird looking, the red one. Okay, the graph's red. All right, notice the tangent line also. I'm sure we talked about this before. The tangent line can cross at another point. That's okay. When we do tangent lines, we're thinking just in a small region. Should it only cross the curve once? And if you zoom in enough, there we go. Now we can see, hey, yeah, it's only crossing through 1 point in this small region. It shouldn't cross through 2 points in this small region. That would make it a secant line. All right, but that's that. If you do have any questions, please let me know. Otherwise, thanks for watching, and I'll see you next time.